So what's going to happen next is I'm going to ask in order each person to sort of give about a 5-minute summary of the conversations in their room. And then we'll take about a 45-minute lunch or dinner break, depending on what time zone you're in. Some of us might hang out on camera. You're welcome to hop on as well at that point. And then we'll come back for 2 more hours and then 1 more readout to close out the day. So with that out of the way, anyone want to go first?
Don't worry.
Thanks, George.
Yeah. So in the dev models room, I'm chairing that one. And the first session was called Perfect versus Good Enough with Jesse Schrader, David Kaplan, and Graham Bury. Hope I got that right. And it started with Jesse and David having a conversation, and then Graham chipped in. But mostly the discussion, and I've taken copious notes, and they're in the HackMD there. I'll make sure that all gets committed. So really the big discussion was the trade-off between the payoff of effort versus the amount of effort we're putting into a security feature. So for example, imagine 10,000 attack vectors. Your solution meets 9,900 of them, but then customers and community people might decide we won't implement this because it doesn't implement that last 100 vectors. And is it worth that extra effort, for that last few percentage, which obviously is usually the expensive one. And then David had an interesting point that was tech is incremental. It has a roadmap. It's a matter of figuring it out like for your business, and usually getting something in place is better than nothing. Some discussions about how some of the laws in Europe are helping, like the GDPR. They don't really tell you how to do it, but they say that you have to take care of the data, which was interesting. And also new versus existing workloads. Obviously, new greenfield deployments will get all the love, and then that doesn't necessarily mean you need to ignore the existing things that are deployment. And then the last tangential one for this session was, what are the thoughts on the impacts of confidential computing enabling bad activities to happen undetected?
Topic.
Yeah, so we kind of talked about, well, this is similar to end-to-end encryption, right? Governments want to do things and things like that. And I thought David's point here was poignant. Who determines what's right or wrong? We just provide a sandbox, and you're paying for time on it. So I thought that was interesting. Some follow-ups, action items, is positioning what the CCC might expect to do with regard to regulators. Is there a relationship there? What's the role there? Informing regulators, what's possible, what's not possible, what's appropriate, perhaps levels of protection, what is good enough, and then clear quantification about vulnerability levels, something deeper than CVEs. It's difficult to determine how many or how much of an attack space have I walled off myself by using certain technologies. Being explicit about threat models, what's in scope, and what's emphasize things that we can do versus things that we can't do. And Kalahari said this quantification will also help customers take a risk-based decision rather than a financial-based one, which I thought was an interesting topic. So that was that session. The next session was Mysticos, which is mostly covered a demo there. We just need to get a link to the presentation of the slides, and there were some questions asked there, mostly around the license, which there was some discussion there. It was complicated, so I don't want to try to summarize put words in people's mouths. Okay. But that's basically what we've talked about so far. Anyone who's in those sessions that I miss a major, I think I got the major points there on that.
Yeah, and questions. On the topic of the CCC and regulators and sort of creating some of that content or guidance for folks, if anyone wants to join, right, the CCC meetings are open. That topic has come up a couple times in the TAC meetings. It's happened every 2 weeks. There hasn't really been a specific action to follow up in the TAC yet, but just a good discussion about it. So if that's an area you want to raise your hand and come help out, I'm sure that the TAC would welcome it. Thanks, George. That's a great summary. Bob, do you want to go next?
Sure. So we kicked it off with cloud-native computing and FAS, functions as a service. This is proposed by Derek Miller, who sort of like started off the conversation for a bit, and then he had to go. So we had a little bit of lull in the middle, and then things picked up with some other folk later. but it really sort of discussed three big challenges. Attestation, where that fits in the entire system. There's a whole lot of moving parts and functions as a service, and there's some design decisions that can be like trade-offs when doing that sort of thing. And that especially comes up with like latency and some other issues with terminating TLS. And then Derek, they're using OpenFast for their sort of thing at Veracruz, and they've modified it internally and might potentially propose some things upstream. And right now, how they do everything is less performant and a little bit hacky, but moving forward with how to potentially make that better. Then there's a general sort of open question to everyone is can I reuse my enclave for another function? It'd be desirable to use it as far as performance goes, but then there's issues with clearing the cache, metadata, and all that other fun stuff. After that, we then sort of dived into a larger conversation with Amar Gouda. I apologize if I mispronounced your last name. Ravi Sahita and Samuel, I missed your last name. Just sort of discussing some of the various issues with functions as a service and this in general. And there's a lot of conversations about transparency and why it needs to be open for it to be truly transparent. And you really can't have something that is both transparent and proprietary. With functions as a service, there are many components that need to be trustable, and that's a lot more than the standard infrastructure as a service type stuff with confidential computing. And I'm pretty much reading off your note in there on that one.
I had a pretty clear point, and folks who've worked with me before know how much I view open source as a tool both to enable us all to build faster, but also to improve transparency. And we need, signed build chains. We need software supply chain security, and we need verifiable build processes to really get there. But even without those, it's still better to be able to read the code yourself than to have to trust everything blindly and just take it on faith that someone doesn't have a backdoor. And I want to see more open source and more open hardware, more open firmware in this space. I think that's the direction a lot of work is going.
The big follow-up is actually the potential creation for a working group to sort of discuss some of the best practices around this. There's a lot of people that are sort of working on this, but people aren't really talking to each other about it, and there's a lot of stuff being done in private. And it'd be nice to come together to actually put together some best practices and solve some of the problems, just what is the right model to incorporate sidecars into all this, especially when it comes to the idea of confidential computing.
Yeah. Thanks, Bob.
Yep. The next session was Ego, confidential microservices with Go. This was largely a demo from Moritz Eckert. Again, I apologize if I mess up your name. I thought it was really cool. It's essentially a drop-in replacement for Go, and being able to compile any Go program with support for SGX. There's also some additional libraries to take advantage of some of this stuff for signing or sealing and unsealing various things in your Go programs. There's also a nice little wraparound or thing called you can do Ego make, so that way you can it functions just like make. So you use that instead of just your make command when building something. The other big question out of all that is Ego itself is very SGX specific, and it is still TBD whether TDX is in its future. However, that will probably be dependent on Open Enclave and its support for that. However, there is going to be an open conversation starting regarding that with Dan Milton's facilitating combo with Intel.
That's an awesome follow-up right there. I know a lot of folks have built stuff. Felix is probably pretty close to your heart on top of Open Enclave and would love to see it support other platforms. Maybe that's a good segue.
I think it is, yes. I'd love to see that, yeah. Okay, so our session, the first one was Introduction to Attestation Use Cases, and that was originally proposed by Mike Purcell, who couldn't attend, so Thomas Hadjono volunteered to host that, so thanks for that. It was an interesting discussion, and we sort of started with historic use cases, which I think was a good way to kick things off. We talked about how TPMs originally introduced the concept of attestation into like general purpose computing, how it was used to attest the health of computers in a certain network, that they booted correctly and so forth, how that then evolved into something called dynamic growth trust measurement, and how that can be seen as a predecessor to what SGX and SEV and so forth are doing these days. Like not measuring the entire boot process, but rather measuring only the relevant parts. Yeah, that was interesting, and we then talked about more contemporary use cases, or the ones that are enabled by the recent hardware, and that quickly went towards supply chains, like software supply chains. How can we attest these supply chains, and what do we actually want to attest? So a very good point was made by Yeoman, that today the discussion is mostly about identity when we talk about attestation, like where did this piece of software come from, who signed it, and what's its hash, what is its hash. But at least from a consumer perspective, what we actually want is attestation of functionality or semantics. Like this piece of code is not writing my data to the internet, or it's not storing my data, or it's only running a certain algorithm on my data. And I think that is a very, very good insight. And this is certainly something that we as a community still need to work on. The conclusion was that there are many interesting approaches in academia, but there are largely no actual practical solutions. And that maybe Project Oak from Google goes in that direction, or Veracruz from ARM, but that this is ultimately where we want to be, and that possibly WASM inside an enclave can help with verifying certain properties, or attesting the functionality of a piece of software running inside an enclave. I like the remark from Dave Thaler that essentially every authentication use case is also an attestation use case. So I think we answered the use case question with that. So there are plenty of authentication use cases, and I really much like that. And yeah, authentication between services, I think is a big topic here. Yeah, that was the first session. Second session was a joint session by Derek Miller and Thomas Fossati. This is where we joined the two stickies. And the first part was about attestation verifiers. And attestation verifier essentially refers to a service that attests, or that verifies an attesting party on your behalf. And like, you don't want to verify that thing on your own. You rely on a verifier service to do the verification for you, and you just verify that verifier once. And we discussed about that in different contexts. We spoke about different IETF proposals in that area. For example, the EAT proposal, which was very interesting and also new to me. we discussed like how do I verify the verifier, which is an interesting aspect. And there were some very good insights. It seems like there's some very interesting work going on at the IETF REDS group. And there was also we briefly talked about Microsoft Azure Attestation service, which is probably currently the only deployment of the only commercial deployment of a verifier service. And yeah, that was interesting.
It sounds like your conversations centered a lot around the software attestation chain and not much on hardware, which I think is interesting. A lot of that is new to me. I've spent more time focusing on hardware attestation and software signing.
Yeah, I think we sort of we didn't much differentiate between software and hardware at that point. In the end, the discussion was around how the verifiers can particularly be useful in IoT context if you have a very restricted device. We can't suppose that it knows about Intel and AMD and ARM and Azure and Google attestation infrastructure, but there should possibly be a service that a washing machine trusts, and this service just say, okay, it's good. Yeah.
Cool.
Yeah, that was that. Very interesting discussions, and yeah, it was quite some engagement from the community, and I think that was good.
Yeah. Awesome. Thank you, George, Bob, and Felix for all the summaries there. I think, folks, we're going to take about a 40-minute break looking at the schedule. We ran a little bit long here, which was great. We're going to take about 40 minutes. We can leave the stage up, and the four of us as moderators plus Karen, the five of us might kind of hang out here. If anyone else wants to hang out and chat with us, you can just click. I think there's a little hamburger icon on the top right to say, hey, you want to jump up on stage, and we can add you. And we'll just pop on and off the stage for a while, and I'll see you all in about 40 minutes. Thanks so much, folks.
Thank you.
Thanks.